Hello everyone and welcome to another lesson. In this lesson, we're going to talk about the quotient rule. So let's just start by taking the function y equals to f of x divided by g of x. Now when we have a function like this, where we have a function over another function, we use the quotient rule. Now what is the quotient rule? The quotient rule is a rule that is primarily derived from the product rule. And how do we do that? So let's take a look at this. So let's say I write the same function y equals to f of x over g of x as a product. So I'm going to write f of x, and I'm going to bring the g of x to the top as a numerator with a degree of -1. So I can write it like this: g of x to the power -1. And now that I have the function y as a product of f of x and g of x to the power -1, I can apply the product rule in this one. So using the product rule, I will get y prime equals to the derivative of the first function, f of x, so it's going to be f prime x, times the second function stays the same, so we're going to have g x to the power -1 plus the derivative of the second function, g of x to the power -1. Now to find the derivative of that, we're going to use our power of a function rule. So that way we have to bring the -1 in the front, and then we're going to have g of x to the power -2 times the derivative of g of x, because g of x is a function itself, and then times the first function stays the same, f of x. So we can simplify this. So we're going to have y prime equals to, we're going to have the f prime x, and then we can bring the g of x down like this, and then we have a -1, so the sign would be a minus, and then we have f of x, this one, and then we have a g prime x, so let me write that one as well, and then we can write the g of x to the power -2 in the denominator as g of x to the power 2. Now if we have to simplify it further, we can take the common denominator of this to be g of x squared. And what do we have over here? We're going to have f prime x times, we already have a g of x, so to get a g x squared, we need one more g of x, so I'm going to multiply that, and minus this one already has the g of x squared, and my common denominator is g x squared, so there is nothing to add over here, so we're going to keep the f of x times g prime x, and that is what we call the quotient rule. So f prime x times g of x minus f of x times g prime x divided by g of x squared. Now, as you can see, I've given you the definition over here. Another way to remember the quotient rule would be that it's always the derivative of the top first and the bottom stays the same. And it's the opposite of product rule. So product rule was plus, this one is going to be minus. Then the top stays the same times the derivative of the bottom. Now we also have to make sure that we keep the bottom square as the denominator. So that is the quotient rule, and as you can see, we can derive it using the product rule. So let's apply the quotient rule and let's do this example over here. So we can see that it asks us to determine the derivative of the function h of x, and the function is 3x minus 4 divided by x squared plus 5. So if I have to find the derivative of this one, so let's take h prime x is gonna be, so as the quotient rule states, the derivative of the top function. So what is the derivative of 3x minus 4 gonna be? It's just gonna be 3. And the bottom function stays the same. My derivative of the bottom function, now the derivative of x squared plus 5 is gonna be 2x, and times the top stays the same, 3x minus 4. Then we have to do x squared plus 5 whole square as our denominator. And then we can simplify this. So the top is going to be 3x squared plus 15 minus 6x squared plus 8x divided by x squared plus 5 whole square. We can simplify it further. It's going to be negative 3x squared plus 8x plus 15 divided by x squared plus 5 whole square. Now you can't simplify it further, so we're gonna keep it to that. So that's how you can apply the quotient rule to find the derivative of a function that is in the form of this. So let's move on and look at this question. Now, by the way, this kind of question is the most important kind of question that you're going to do. And it is the most common question that you will get in the course calculus, in any calculus course actually. So if we read the question, it says determine the equation of a tangent y equals to 2x over x squared plus 1 at x equals to 0. Now let's understand the question first. What did it ask? It asked us to find the equation of the tangent line. Now it asked the equation for the tangent line. So we know that a tangent line is a straight line. And what is the equation of a straight line? The equation of a straight line is always y equals to mx plus b. So we know this. So what we're going to do is, we're also given with the value of x, and then we're also given with the function to which this will be my tangent line. So the tangent line has a slope, and that slope will be the derivative of this function. So let's first find the derivative. And to find the derivative, we're going to use the quotient rule. So y prime is going to be the derivative of the top, which is going to be 2. The bottom is going to stay the same, x squared plus 1 minus derivative of the bottom, which is going to be 2x, and the top stays the same, divided by the bottom whole square. So x squared plus 1 whole square. Now, in a situation like this, you can simplify it further, but if you are given with the value of x, there is no need of simplifying it. You can just plug in the value of x and then you can get your derivative. So let's plug in 0 in place of x. So we're going to get 2 0 square plus 1 minus 2 times 0 and again 2 times 0 divided by 0 square plus 1 whole square. So as you can see, 2 times 0 and 2 times 0, this is going to be 0, so we don't really need to worry about that. This is going to be 0 square plus 1, which is going to be 1. 2 times 1 is 2. And in the bottom, we're going to have 1 square, which is going to be 1. So we end up having the derivative as 2. So now we have our slope, the m value of the equation. We have our x value. If we plug in this x value into the original function, we're going to get our y value. So let's plug that in. So y equals to 2 times 0 divided by 0 square plus 1. This is going to be 0. So now we have our x value, which is 0. We have our y value, which is 0. We have our m, which is 2. So we can find our b. So b is going to be y minus mx. Now how do we do that? We just follow the rule of solving an equation. We isolate b to solve for the value of b. So b is going to be, in this case, 0 minus 2 times 0, which will also give me 0. So finally, we get our equation for the tangent, which is going to be y equals to, my slope is 2x plus 0, so you don't really need to write that. So this is my equation of the tangent. So I hope you guys are clear with the quotient rule and you guys know how to apply it to find the derivative of any function. So thank you so much. I appreciate each and every one who has been hanging on so far, and you guys are doing great. So I'll see you in the next lesson.